What's up, CalcuBots? In this video, we're going to talk about a theorem called the Remainder Theorem. And I have it written right here on the left. So the Remainder Theorem states the following. If a polynomial P of Q is divided by x minus k, then the remainder is the value of P of k, right? And we're going to do a few problems. We're going to use the Remainder Theorem to evaluate the functions that I have, all right? Oh, I'm sorry. I forgot a period. Punctuation is key. All right. So for number one, I have this following problem for us. All right. So we're going to take a polynomial P of x, right? So our P of x polynomial, I use P of x because P for polynomial. It is a function, but I like P of x just because it reminds me that it's a polynomial. So our polynomial P of x is x to the fourth minus 9x squared plus 14. So that's a polynomial. So if a polynomial P of x is divided by, right? Divided by, and in this case, I have x minus 2, right? Then whatever this is, whatever the remainder of this is, should be P of k. In this case, keep in mind that it's x minus k. So in this case, my k value, right? So right out the bat, my k value is equal to 2. So that means that the remainder, right, of my polynomial, of this polynomial, will be P of 2. That's my polynomial. So whatever my remainder is, it'll be the value P of 2. All right? So let's use the remainder theorem to solve this. All right? So first things first, to find what P of 2 is, well, let's just use synthetic division, right? So I have 2, and I'm going to use synthetic division. I noticed that my polynomial is missing an x cubed term, so I'm going to have to put 0. So 1 for the x fourth, 0 for the x cubed, negative 9 for the x squared. There's no x term, so it's a 0 again, and a 14 for the constant term. Just like that. All right. So let's do our synthetic division. Right. So we drop down the 1. 2 times 1 is 2. Add 2. 2 times 2 is 4. Add negative 5. 2 times negative 5 is negative 10. Add negative 10. And 2 times negative 10 is negative 20. Add negative 6. So my remainder is negative 6. But let's use the remainder theorem to check if it's true. So let's calculate P of 2, right? Which is I have up here. So P of 2 is equal to x to the fourth, which is 2 to the fourth, minus 9 times 2 squared, plus 14. All right? So let's keep going. 2 to the fourth is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 minus, well, 2 to the second power is 4. 9 times 4 is 36, plus 14. All right? And 16 minus 36 is minus 20 plus 14 equals negative 6. Look at that. The remainder theorem holds true. That's how we do it. Pretty cool. So with the remainder theorem, if you only want the remainder of the polynomial, you don't need to do all the synthetic division. In fact, if the remainder is 0, then that means that x minus that remainder is going to be a factor, right? X minus 2 is not a factor of this polynomial because we don't get a remainder of 0. But if we do get a remainder of 0, which we can quickly calculate with the remainder theorem, then we know that a polynomial divided by it would be a factor of it. All right? Let's see if we can find one in the examples I have prepared for you guys. So let's move on and see what we get. All right, so I have another example for you guys. Here we go. Let me get rid of all this. All right, example number 2. I have prepared this polynomial. So P of x is going to be 3x cubed minus 2x squared plus x minus 4 divided by, and our polynomial that we're dividing by is x. It's going to be a little funny, x plus 3. Be very careful. We have an x plus 3 here, but the remainder theorem says it has to be in the form x minus k. So our k value is not actually 3, right? Let's rewrite this one so that it's in the form of x minus instead of x plus. All right? Let's rewrite it. Here we go. I'm going to rewrite this one, okay? I'm going to rewrite this as 3x squared minus 3x cubed, apologies, minus 2x squared plus x minus 4 divided by, watch this, x minus negative 3. So our k value in this case is negative 3, not 3, okay? Negative 3, because it has to be in the form x minus. All right, cool. Let's use synthetic division to divide this and see what our remainder is, and then we're going to apply the remainder theorem to confirm it. All right? So here I go. Where am I? K was already that. All right, so minus 3, right? You know, I'm just going to use this right here to save some space. The coefficients of my polynomial are 3, negative 2, 1, and negative 4. And let's get our bar going. Let me actually move it down a bit to give myself some more room. That should be enough. And let's bring down our first term, 3. So negative 3 times 3, negative 9, add negative 11. Negative 3 times negative 11 is 33, add 34. Right? Right. Now negative 3 times negative 34, I have a calculator. Negative 3 times, not negative 34, sorry. Negative 3 times 34 is 102, negative 102. Add negative 106. So my remainder is negative 106. So clearly x plus 3 is not a factor of the polynomial. Let's apply the remainder theorem to check what it is. So P of negative 3, just like that. It's going to equal 3 times negative 3 cubed minus 2 times negative 3 squared plus negative 3 minus 4, just like that. Okay, let me zoom out just a bit and let me move it so we can have it within view. All right, negative 3 cubed is negative 27. Negative 27 times 3 is negative 81. So this is negative 81. And then minus 2 times minus 3 squared is negative 18. Minus 18. Yeah. Minus 3 minus 4. So negative 81 minus 18 minus 3 minus 4 gives me negative 106. There we have it. We're golden. Very, very interesting and very, very cool. All right. Let's move on to another example. Let me erase all this. Oh boy, what happened? Sorry about that. I think I clicked back on my mouse. All right. Sorry about that, guys. A little delay. Oh my Lord. Let's just do this. And the remaining. All right, cool. So another number I have prepared for you guys is this one. All right, we have x to the 4th plus 5x cubed minus 4x minus 17. So that's our polynomial divided by x plus 1. Again, it happened, right? So this is actually going to be x minus negative 1, right? It's the same thing. So therefore, our k value is negative 1. So let's use division again. Just looking at my notes, guys. Apologies for the little delay. All right, cool. We're gonna use synthetic division one more time, and to solve this. All right, to get the remainder. All right, so let's take our coefficients. 4, 3. Oh, it's missing 2. Keep that in mind. It's missing this the square term, but it has 1 and 0. Okay, so 1, 5, 0, negative 4, negative 17. All right. And let's do math now. Bring down the 1. Right? Negative 1 times 1, negative 1. Add 4. Negative 1 times 4, negative 4. Add negative 4. Negative 1 times negative 4 is 4. Add 0. Negative 1 times 0 is 0. Add negative 17. So according to this, our remainder is negative 17. Let's calculate it to make sure. I'm going to do it off to the side under the remainder theorem right here. So P of negative 1 is equal to negative 1 to the 4th power plus 5 times negative 1 to the 3rd power minus 4 times negative 1 minus 17. Anytime you raise a negative to an even power, it becomes positive. So negative 1 to the 4th power is just positive 1. When it's raised to an odd power, it's negative. So 5 times negative 1 cubed is the same thing as 5 times negative 1, which is negative 5. Negative 4 times negative 1 is positive 4 minus 17. Negative 1 minus 5 is negative 4 plus 4 is equal to 0 minus 17. Negative 17 is our answer, just like we calculated. Awesome. Very cool. All right. So now we don't need to be calculating the synthetic division to find the remainder, right? What's the remainder? Oh man, you're telling me I have to go through all this whole division? No, we can simply use the remainder theorem and it'll give us the result we want. Very cool. So for this next one, we're not going to be using synthetic division anymore. We're just going to straight up be calculating it. All right. So let's calculate the next one. I have for you guys negative 3x squared plus 6x plus 24 divided by x minus 4. In this case, we know our k value is equal to 4, right? Because it's already in the notation of p minus k. I mean x minus k. So because it's x minus k, x minus 4, k is equal to 4. So now let's calculate it. So p of 4 will give us our remainder. Okay? That'll give us our remainder for this function. So let's find out what it is. All right, let's get our remainder going. So negative 3 times k squared plus 6 times k plus 24. So now I'm going to plug in my 4's in here. All right, cool. 4 squared is 16. 16 times negative 3, I don't know. Negative 48. Plus 24 plus 24. Hey, wait a minute. Negative 48. I know 24 plus 24 is 48. 0. That means that x minus 4 is a factor of this polynomial because the remainder is 0. So we can safely divide it, and we know that it's good, that whatever is remaining is going to be a factor of it. So why don't we do that to get what our other factor is? Okay. So we know x minus 4 is a factor of negative 3x squared plus 6x plus 24. We know it's a factor because the remainder is 0. We don't know what the other factor is, though. The remainder theorem just tells us what the remainder is. It doesn't directly tell us what the other factor is. So to do that, we need to do synthetic division. So let's just do it real quick on the side right over here. So we know 4 is a factor, right? X minus 4. 4 is the root. So minus 3, 6, and 24. Let's do quick maths. Quick math. Don't call it maths. All right. 4 times negative 3 is negative 12. Add negative 6. 4 times negative 6 is negative 24. Add 0. So that means that our other factor, this is going to equal negative 3 x minus 6. So if we multiply x minus 4 with our new factor, right, we get the polynomial back. Negative 3x minus 6. this will equal negative 3x squared plus 6x plus 24. Very, very cool. So the remainder theorem gives us a quick glance at if we pick a value for k, then that means that x minus k is going to be a factor if the remainder is 0. Okay? So that's how we can use it real quickly. So let's move on to another example I have for us. Which one did I just do? Okay, we have 3 more. Let's do it. That way you guys don't have to waste your time, doing synthetic division only to find out, oh my god, it's not a factor. All right? So we can apply it with other things. Maybe we can apply it to another one called the rational roots theorem. We'll go over that in another video. So we have x to the 4th minus 1 divided by x minus 4. Cool. Is x minus 4 a factor of x to the 4th minus 1? Well, let's use the remainder theorem to find out if it is. Because if it is, then we can find the other factors. So in this case, k is equal to 4. Right? Remember, it's only this number right here, not the minus. Look at the remainder theorem, x minus k. Right? If it was a plus 4, then it would be minus 4. But because it's already minus, we just take the number that's next to it. So let's calculate it to the 4th power minus 1. Is x minus 4 a factor of x to the 4th minus 1? I don't know. Let's find out. We get 4 to the 4th power. Well, that's a big number. 256. 256 minus 1 is 255. This is a remainder right here. It's not 0, so x minus 4 is not a factor. Womp womp. Womp womp womp. Okay? So let's do... What is the polynomial though? I don't know. Why don't we find out? Let's just do quick synthetic division. This is why I like synthetic division. It's fast. 1, no x cubed term 0, no x squared term 0, no x term 0, and negative 1. So 4, 3, 2, 1, 0. All right, we're good. Let's do synthetic division real quick. Drop the 1, 1. 1 times 4, 4. Add 4. 4 times 4, 16. Add 16. 4 times 16. I don't know. Let me do it. A calculator. 64. Add 64. 64 times 4. Jesus. 256. Add 255. Just like we calculated from the remainder theorem. So no, x minus 4 is not a factor of x squared minus 1. It is not a 0. Because it doesn't give us a 0. Okay? All right, let's do another one. I said 3 more. I think we have 2 more left. So let's calculate them. So it's a quick way to check for factors, okay? For zeros, the remainder theorem. I have this one for us. 3x to the 3rd power plus 4x squared minus 8x plus 2 divided by, what are we dividing by? We're dividing by x minus 3. Okay. Let's apply the remainder theorem. So if a polynomial p of x is divided by x minus k, which is what's happening, then the remainder is the value p of k. So let's find p of k. P of k, which in this case is p of 3. Let's find out what a remainder is. If it's 0, then we do have a factor. So 3 times that plus 4 times... I'll fill it in a bit. I'm just writing it down so I don't have to be switching colors all like all the time. If you guys like that I color code it, please let me know. It helps me keep track of my math. But you know, if it doesn't make sense to you guys, then that's fine. All right, let's do math. 3 times 3 to the third power. 3 times 3 to the third power is 81. Plus 4 times 3 squared, which is 36, minus 24, plus 12. 81 plus 36 minus 24 plus 12 gives me a remainder of 105. Unfortunate, this is not a factor. Let's use quick synthetic division to do it right here on the side. 3, 4, negative 8, and 2. All right, they gave us everything we needed. We did not need to add any zeros. Very cool. Let's keep going. 3 times 3, 9, add 13. 3 times 13, 39, add 31. 3 times 31 is 93. Did I do something wrong? 3, 4. Is my math wrong? No, well, I mean, let's keep going. Add 95. I'm missing 10. Did I do something wrong here? 3 times x cubed plus 4x squared minus 8x plus 2. Hold on. I must have done something wrong. 3 times 3 cubed plus 4 times 3 squared. Right. I'm just checking my math on my calculator, guys. Please excuse me. Squared minus 8 times 3 plus... Oh, this is 95. I did something wrong right here. This should be 95. I must have not added a 10. Subtracted a 10. 95. So our remainder theorem holds. Apologies for that confusion. Hopefully you guys caught it during the video. But, you know, if we catch mistakes, that just means we're being careful. All right. Cool. All right. And we have one more example for you guys. All right. So 95, therefore, x minus 3 is not a factor. Okay. One more example, and then we're done with the remainder theorem. We're probably going to use this again when I do other calculations, especially when we go into something called the rational roots theorem. But in the meantime, let's just worry about this for now. I have the following polynomial. Let me write bigger. 4x cubed plus 5x squared minus 2x plus 7 divided by x plus 2. Let's rewrite this because it's not correct. X minus negative 2. Just like that. Remember, it has to be in the form of x minus k. So in this case, k is equal to negative 2. Awesome. All right, let's apply the remainder theorem to see if x plus 2 is a factor. So the remainder is the value p of k. So p of k is equal to 4 times x cubed plus 5 times x squared minus 2 times x plus 7. And let's plug in negative 2, negative 2, negative 2. All right, awesome. 4 times negative 2 cubed, I know is negative 8. 4 times negative 8 is negative 32. Plus negative 2 squared is 4. 5 times 4 is 20. Plus negative 2 times negative 2 is 4 plus 7. This gives me negative 12 plus 4 plus 7. Negative 8 plus 7 equals negative 1. So the remainder is negative 1. Okay, that's the remainder. Let's use synthetic division, and then we're done. So k is negative 2, 4, 5, negative 2, and 7. Drop a 4. 4 times negative 2 times 4 is negative 8. Add negative 3. Negative 2 times negative 3 is 6. Add 4. Negative 2 times 4 is negative 8. Add negative 1. And there you have it, the same remainder. I hope this gives you guys a little bit of an idea of how to apply the remainder theorem and how it's used. We're going to keep using it in the future, right? So keep it in mind. And write in your notebooks, make sure you understand what it's saying. Be very careful with the when you're dividing by x plus 2, like in this case, you have to make it match the x minus k format. So instead of x plus 2, it was x minus negative 2. That means our k value is negative 2. A lot of times students will see this and immediately assume that k is equal to 2. That's not the case, okay? It has to be in the form x minus k, all right? Which means that our true k value is negative 2. So just keep that in mind. I hope this clears things up, and I'll catch you on the next one. Peace.